So, a very good day, children. I'm back with chapter number 3, the third chapter, but it is actually chapter 8, Exponents and Powers. We have finished with rational numbers. You have done mac on rational numbers, 2 macs. You've done pie chart, and then you did histogram, where you did another mac. Now we will begin with chapter 8, that is exponents and powers. But before we start, I must remind you, please check diksha.gov.in. That is a very good portal where you get lot of explanations about the questions that we are putting up, the themes that we are putting up, all these concepts also. Delta step, you have all of you have already registered, and please keep doing the sums. Very soon assessments will be posted. Another new thing is MindSpark, which has been given to you. Please enter into it and start solving the sums. The ID and password has been given to you. When you open MindSpark, you will be opted to change the password, so please do that, but do not give your parents' email ID or phone number. So let's begin with exponents. What is an exponent? An exponent refers to the number of times a number is multiplied by itself. For example, 2 to the third means 2 raised to power 3. That means it is 2 into 2 into 2, which is equal to 8. 2 raised to power 3 is not equal to 2 into 3. 2 raised to power 3 means 3 times 2. 2 into 2 into 2. It is not same as 2 into 3, which is equal to 6. And remember that a number raised to the power of 1 is always the number itself. For example, 2 raised to power of 1 is 2. How does an exponent look like? See, 2 raised to power 5. The 5 number which is there is a little smaller than the main number because it is known as the exponent, while 2 is the base. You must have seen in MS Office that when you write all these things, you get a option for superscript or subscript. So this is the exponent is written in superscript. Before we begin further, we need to know the exponents rules or the laws. Now, I will just make it a little more clearer. There is a first product law. First product law means a raised to power x into a raised to power y is always equal to a raised to power x plus y. That means when the bases are same and the powers are different, the base can remain the same and the powers are added. This is the product rule. Next we have the quotient law or quotient rule. Same thing, but it is in division now. A raised to power x divided by a raised to power y will actually become a raised to power x minus y because it's in division, so it becomes x minus y. Next we have power rule or power law. It is a raised to power x whole raised to power y. See the difference between product and power. Please see the difference. There it was ax into ay. Here it is ax whole raised to power y. Here the powers are multiplied. A raised to power xy. It does not become addition. It is a raised to power xy. Power of a product rule. Power of a product rule is like AB. The product inside is same, there are two numbers, but both of them are raised to power x. So it is therefore going to be a raised to power x into b raised to power x because both of them are raised to power x. Now come to the fraction rule. Same way, the power of product rule, now power of fraction rule. Now a divided by b whole raised to power x is equal to a raised to power x by b raised to power x. Next we have the 0. zero exponent or the zero power law. A raised to power 0 is equal to 1. Forever remember, a raised to power 0 is equal to 1. Negative exponent, if there is a raised to power something which is a negative exponent, the negative exponent means it will become the reciprocal. So a raised to power minus x will become 1 by a raised to power x. And the last one, the law, is a raised to power x by y. Now a raised to power x is as it is, but 1 by y actually becomes under root y. That means suppose it is a raised to power 2 by 3. So a square as it is, the 1 by 3 becomes third root of a. I will keep explaining these things as and when the sums come. Okay. So these are the 7 rules, 8 rules which you have to write very clearly in your notebooks. This is a must. Laws of exponents should be there in your classwork notebooks for now in sheets. Let's do the first example sum now. Evaluate 2 by 3 whole thrice into 2 by 3 whole twice. Look at the answer. 2 by 3 whole thrice into 2 by 3 twice is equal to, like I told you, the first law, 2 by 3 is the same base, so powers become added, 3 by 2. So 2 by 3 raised to power 5 is equal to 2 raised to power 5 by 3 raised to power 5. Now when you multiply 2 5 times, 2 into 2 into 2 into 2 into 2, it becomes 32. Similarly, 3 5 times, it becomes 243. So that's our answer. Please do this sum. Now there are 2 more evaluation sums. These are examples. You have to do them. First one is minus 1 by 4 whole raised to power minus 3 into minus 1 by 4 whole raised to power minus 2. Again you can see that the bases are same. So because it is minus 3 and minus 2, what we do is that reciprocal thing, because it has a negative integer, so we have to change it into reciprocal. So minus 1 by 4 becomes 4 by minus 1 raised to power 3, and minus 1 by 4 raised to power minus 2 becomes 4 by minus 1 raised to power 2. So minus 1 comes up, therefore finally we have minus 4 raised to power 3 into minus 4 raised to power 2. It is mandatory that we cannot keep the power in minus, unless it has been asked. There are some questions where it is asked that put it in negative exponent, but otherwise the standard form is that you can't do it. So therefore we changed it. Now minus 4 is common. Minus 4 raised to power 3 plus 2, that is minus 4 raised to power 5. And then when you multiply minus 4 into minus 4 into minus 4 into minus 4 into minus 4, that's why the minus remains. Had it been minus 4 raised to power 4, it would have been plus. But minus 4 raised to power 5, so the minus remains and the answer becomes minus 1024. You need to do these 2 sums as well, please, as classwork. Evaluate minus 3 by 2 whole twice raised to power whole raised to power minus 3. So this is which law are we going to use here? The power law. So minus 3 by 2 whole raised to power 2 into minus 3. So minus 3 by 2 whole raised to power minus 6. Again, as I told you, we cannot leave the power in minus. So in order to change it, we have to do reciprocal. So it becomes minus 2 by 3 raised to power 6. So now if you open up minus 2 raised to power 6, it becomes 64. And minus 3 plus 3 raised to power 6, it becomes 729. I think many of the laws have been used in these 3 sums. So you have understood how the laws are applied. Let's do question number 92 and 93 of your exemplar. First one is 92. Express 3 raised to power 5 into 3 raised to power 3 raised to power minus 5 into 3 raised to power minus 4 as a power of 3 with positive exponent. First thing in the answer is, we will mention which law we are using. Everywhere, wherever we are using anything, we must mention which law we are using. So this law, a raised to power m into a raised to power n is equal to a raised to power m plus n. Which law? This is the product law. So product law is being used here. So 3 raised to power minus 5, 3 raised to power minus 4, it becomes 3 raised to power minus 9. And we cannot leave it in minus. So the answer becomes 1 by 3 raised to power 9. Question number 93. Express 16 raised to power minus 2 as a power with the base of 2. Understand the question. It is the power should be in the base of 2. Now we know 16 is equal to 2 into 2 into 2 into 2, which is 2 raised to power 4. Now we got the base 2. Now 2 raised to power 4 whole raised to power minus 2, because 16 was